Everyone is scared of little bits of water falling from the air onto them, but then they'll go jump in a pool and swim around, and that's okay. So we're simulating a raindrop today, but in fact, we're actually simulating it on its side, not head on onto the flow. The reason why is because a raindrop is actually very aerodynamic as long as it stays in shape. And fun fact, a raindrop, it doesn't actually look like this. It when it falls from the air, it really deforms with the air impacting it. But this is the idealized shape of it. So I put it on its side to make it more enjoyable in terms of the wakeness. And we can see it is far more enjoyable this way. We can see that there's an unsteadiness. And interestingly, because it's a bluff body, we see that there's a periodic shedding of the flow. And interestingly, we have another simulation, another video showing a different view. But from this view, I can just tell you that it's not really a von Karman street, strictly speaking. It's a little bit different, and that's because of the tapering up to the point at the top. So there's actually shedding around the sides and from the bottom, and then from the top a little bit as well. So there's this three-dimensionalness to it, and we get this asymmetry in the shedding. Whereas a regular von Karman street, when you shed, it's quite symmetrical about the free stream axis. Whereas this isn't. Obviously, the flow goes up at an angle, and that means that the flow from underneath is actually being redirected upwards a little bit, and this raindrop is actually producing a little bit of downforce then, as long as it stays in the shape, of course. And this is the other view that I was talking about. This is from the top, and we have the Z-plane coming through. And you can see that there is a periodicity to the shedding, but it is not a von Karman street, because a von Karman street has the asynchronous nature to the shedding of each side. So one side will shed first and the other one, and then vice versa. Whereas these ones both shed at the same time from each side. That means that the flow coming from underneath the raindrop is actually dominating the shedding of the entire bluff body. It's really cancelling out the von Karman street that would occur around the sides of the cone effectively. And also the tapering up to the top means that von Karman street would be different to begin with, because the point at which the flow will separate will be different as well. So there's a lot of three-dimensionalness to this fluid here. So that's in the simulation. Make sure to like, subscribe, and if you have any other objects you want us to look at, let us know in the comments below. And if you want to get better at CFD yourself, check out our courses. We also do theory courses as well, where we talk about stuff like von Karman streets. And I'll see you in the next podcast. Peace out, amigos.